Software Engineering Radio, episode 96, interview with Krzysztof Czarnecki. This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome, listeners, to yet another episode of Software Engineering Radio. This is the long-awaited Czarnecki interview. Many people have requested it. Before we get to the actual content, let me remind you that we have our SE Radio get-together open space conference in autumn, actually on October 16th and 17th in Zweibrücken, Germany. The deadline for submitting the little small position papers that we want you to write is coming up. We already received some, so please go ahead, send us the stuff, and we'll be looking forward to meeting you there. Okay, so much for the administrative stuff. Let's go ahead with today's content. Once again, we're at JAU this year in Aarhus, Denmark, and we have another interview. This time it's with Krzysztof Czarnecki. I probably butchered the first name as usual. So Krzysztof, please introduce yourself and maybe tell people how to pronounce your first name correctly.
Thanks for the introduction. I'm Krzysztof Czarnecki, and actually proper pronunciation would be Krzysztof Czarnecki. Mm-hmm. It's a Polish name with a lot of consonants in it.
Yes.
If you know how to read Polish, it's easy. Otherwise, just stick to Krzysztof.
Yeah. Okay. So I guess several people, well, most people probably know you. Actually, we had a couple of explicit requests for an interview with you in our recent listener survey. So you're the thing you're known for is basically generative programming. So why don't you give us a little definition of what this is all about and maybe distinguish it from generic, because some people mix that up, as we learned today.
So the whole idea of generative programming is probably best explained by comparing it to generic or generic programming. If you look up the dictionary, if you look up the word generic, it essentially tells you that it's descriptive. It's a concept about being descriptive of a family of things or concepts. And generative adds something to it. It's about being procreative, about the knowledge of how to instantiate or create instances of those concepts. So it adds this notion of automation on top of just having highly configurable components, which would be generic.
You wrote this book called Generative Programming, the black book with a white paper cat on it. So most people, I guess, know that. Or if they know you, then it's this book from which they know you. So this book has been, I think it was published in 2000. So what do you think, how did the field evolve? What do you think about all those, model-driven development, DSM, domain-specific visual modeling, MDA, all that stuff?
First of all, I should say that it was a collaborative effort with Ulrich Eisenecker.
Absolutely, yeah.
And at the time when we started working on it, I was actually at the Daimler-Benz, later Daimler Chrysler Research Center in Ulm. At the very beginning, I was still working on my PhD thesis, actually just about 1 year into my PhD thesis in 1996. And Ulrich, originally he was my supervisor from the Daimler side, industrial part.
Oh, he was also at Daimler Chrysler.
Yes, but he left. So he was supervising my master's project, and then he left just after I started doing PhD. And at that time, we actually at the company we were looking at things like components and component repositories, how to do reuse, how to find components in those repositories, how to classify things. And it was interesting that after Ulrich left Daimler, he went to the University of Heidelberg, I think, the Applied Sciences University at Heidelberg. We still kept in contact, and one day we had a call and sort of asking each other what what are the interesting topics that we could work on. And then it was interesting that we kind of both resonated on the idea that it somehow just storing concrete components in repositories and trying to find them, it's kind of comparable to a needle in a stack and trying to find it. That the right way would be to have those components kind of created on demand from some kind of knowledge about how those components should solve a particular problem and a specification of the component.
Yeah. I think there are two common misconceptions about the book. One is generative programming equals template meta programming. I kind of think it, maybe in retrospect, you maybe think you shouldn't have emphasized the template stuff so much, because many people got put off by that because they thought that's kind of the same thing. Would you agree, or is that, or what do you say about that? I mean,
well, first of all, before kind of working on the stuff that ended up in the book, my experience was more with Smalltalk, and it was actually Ulrich Eisenecker who dragged me into C++. But then playing with templates was quite a bit of fun, and one of the interesting things was was more of a discovery what's all possible with templates. And seeing that you can actually put some smartness into libraries in terms of using those capabilities to do automatic configuration. And there are a lot of quite practical, useful things you can do with it, although it's very easy to abuse. And the reason why we took this for our examples was just because it was an off-the-shelf technology. It worked without special tools, and it just demonstrated that a language can actually support meta programming, although perhaps it wasn't designed to do so. But we just explored as one example, right? So
another thing you kind of publicized quite a bit with the book was the idea of feature modeling for variability analysis. That's a concept that's known from product line engineering. So how do you see the relationship between product line engineering on the one hand side and generative programming stuff on the other side? Is it the same thing in some sense?
Well, so as I mentioned, we started with our issues with components and reuse and so on. In fact, a lot of the things that went into the book and into those ideas originated from the area of software reuse, domain analysis. In fact, at some point, this concept of software product lines came and was essentially kind of a reinvention of the area of reuse. The area, the field reinvented itself in a form that made it much more close to what companies were interested in. By bringing in more than just the technical issues, by bringing in the fact that product lines are things that in the end are of interest to customers, and also the managerial and business issues, organizational issues have to be taken into account. So in a sense, we started with all of that, and we looked at how those techniques that allow you to look at a domain and analyze it and see what concepts you have, how to scope it, how this could be used in a systematic way to then go on and create, for example, libraries that give you domain-specific languages, and code generators is just one technique to implement it. And in a sense, we sort of tried to put it all together into a holistic software development approach. We call the book Generative Programming rather than Generative Software Development, just to sort of say and focus the attention that this actually is about something where working code is coming out. And that's very often what happens with any kind of new technique. But the book is actually covering the whole set of requirements and architecture and implementation issues. And feature modeling is just one of the important ways to look at variability in requirements. That's why it was part of it.
In previous episodes, we talked about feature models and product line stuff. Recently, you've been talking about cardinality-based feature models. Can you briefly update our listeners what this is all about?
So, for example, in the book, at some point, we were sort of looking, I think it was in chapter 4, when the chapter 4 describes feature modeling, and there the form of feature modeling described is a very simple one where you just talk about features and that are mandatory or optional, and they can be alternative or inclusive or. But essentially, you say whether a feature is there or not. but you never have like multiple instances of a feature.
Yeah.
And when you look at a system sort of at a very high level, at the level of requirements, very often it's enough to sort of just say what properties the system will have in terms of the absence or presence of a property. And not very often you have to talk about that you have several instances of some concept or some feature. This rather happens when you start moving closer to architecture and to the runtime code of a system. So, for example, when you start talking about components and so on, you have to think about how many instances you have of them and how they are connected. And feature modeling actually can be used at any level, whether it's requirements or whether it's design architecture and even close to code. And once you move there, you kind of require to use cardinalities, and that's something that was actually not in the book, but realized later that it's a useful thing.
Okay. Let's again briefly come back to these other acronyms. If I talk about model-driven development, I always say MDA is a special kind of the general MDD approach. And I always have a hard time of kind of classifying generative programming and MDD, which is the more general case. It's clearly which is historically the one that has been there first, GP. Clearly, I mean, MDD is a term that's at least in the mainstream 5 or 6 years old. Yours is older. So how do you see the relationship between these different things, generative programming and DSM? Well, DSM is just drawing pictures. It doesn't necessarily generate code, but the MDD, MDA world and the generative programming world, how do they relate?
So I've been looking at model-driven development for at least 5 to 6 years.
Yeah.
And there's not much talk about those terms in the book because just at that time it wasn't present in that form. However, I got interested in that because surely there is a lot of commonalities between model-driven development and the ideas from generative programming. And the things that I wanted to explore is to see what is common, what are possible synergies, what are the things that are different. And one thing that I observed early was that in model-driven development there was at least in the early days of it, a lot of focus on things like platform independence. So in that sense, supporting variability across different platforms.
Yeah, that's the MDA kind of
MDA
trademark
kind of
thing. Yeah,
exactly. And without sort of telling you what does it mean to be platform specific or platform independent? What is a platform? And this is something that actually is sort of a central theme to domain analysis or to product lines, where you sort of scope a domain and say, well, this is my problem domain, this is my solution domain of technology space. And this allows you to sort of delineate and say, well, something is it's part of the platform or it's part of the solution domain or not. And that depends on a lot of factors, including strategic factors and so on of a company. But at least with domain analysis, you have a systematic way to talk about that, whereas it was completely absent in the MDA world at the time.
Yeah.
Later, I saw that, and I guess I also worked myself in that area, and many other people, like including you, Marcus, to sort of bring together the idea of modeling and software product lines, and by that it definitely very much gets closer to the spirit of generative programming by sort of looking at a domain, trying to make it more operational in terms of having the knowledge to create instances of concepts in the domain, to automate as much as possible. So in that sense, it's getting very close. Still, I think there are sort of disparate. I can see still disparate communities and a lot of potential for further synergies and integration.
Yeah, I mean, that brings me to the point that I've complained about in previous episodes already. I mean, the community overall is relatively small compared to other mainstream things, and then there is still 15 different buzzwords. I mean, DSM, MDD, MDA, GP, and you can go on, software factories, DSL tools. I mean, it's basically all the same thing. Everybody puts their own spin on it, but it's frustrating that the community or the communities can't agree on a common set of terms.
Well, it's bad and good in a sense, because if you have an area where everyone is agreeing on everything, then the area is probably pretty much dead. It's not advancing very much. It's not an exciting place to be.
No. I mean, sure. I'm not saying that people should agree on all details, but you can't even agree on what a model is. Some people call things meta model, others call it domain model, whereas others call models domain models. So it's completely confusing. It's not about harmonization of the approaches and the ideas, but a couple of basic terms at least that would be helpful.
I absolutely agree. I guess those things just take time.
Yeah.
So I make sure, for example, when I give a talk, to define those models. Define those terms. For example, model, meta model. What I mean by that, I very much try to avoid to use the word meta. Very often, it's enough to say model, and you have to just make sure that you define all the words you're using.
Yeah, sure. Yeah.
I don't know. I'm not sure you can do more than that.
Yeah, no, probably not. Okay, so I don't know. I don't remember. Did you actually say what you do these days, where you work? That you're a professor? Did you say that in your introduction?
No, I didn't.
Okay, no problem. So that brings me to the point that you're actually doing research today. So what's the kind of stuff you're working on today?
As I said, I wanted to explore first the relationship between generative programming and model-driven development, and sort of that pushed me into looking at a lot of the things that exist in the modeling world and so on. And one of the interesting problems there is the question of what is the language to represent models, and domain-specific languages is certainly a concept that is quite important in generative programming and increasingly important in model-driven development.
Yep.
So the question is, where do we take those domain-specific languages? How do we come up with them? How do we develop them systematically?
Yep.
And I've been working in this area for quite a while, and sort of maybe a number of years after moving to, I moved to Waterloo 5 years ago.
Yes.
And up to about 2 years ago, I was looking at modeling at fairly requirements level. But my problem at some point was it was very difficult to evaluate the work, see whether it actually brings value or not. Because there's just simply not, it's a catch-22 problem. There's simply not enough models being used out there that you could use as a way to scientifically study the practices and try out your techniques. So I sort of also wanted to have models where something running comes out. So that sort of moved me to look into models that are closer to architectures, closer to frameworks, closer to code. And then sort of the question how you can get those modeling languages there in this context and work with them. And that's sort of the topic of my work today. For example, how to create domain-specific languages from APIs of platforms and frameworks.
In the MDD world, people have always been saying that DSLs and modeling languages and frameworks are two sides of the same coin. That if you have a DSL from which you generate code, then there is always this framework against which you generate. So what you do is you go the other way around. You say there is a framework. Now, how can we find the language that describes, a framework, how do you call this, instance, a configuration or a program that uses the framework correctly, okay? Is this correct?
Correct. So in this work, the key idea is to sort of look at the API and say, well, the API provides you with some concepts that you, for example, as an application programmer, will instantiate in your application code and allow you to create applications. But very often those concepts are just not explicit in your code. They're scattered and tangled across the whole code base, and making that explicit, that's where DSLs come in. But you can also see it sort of the other way around and say that by creating frameworks and improving them, evolving them, you sort of grow the DSL in an incremental way.
So that means that the model is relatively close to the code. In some sense, it's not like you have a rectangle that becomes a class, but there is a direct relationship between what the model describes and what the code does, how it does it, what the code looks like. So this probably allows you to do some kind of round-trip engineering, I guess, maybe, I hope?
Yes, that's true. The models are not as close to the code as you would say that they are just a simple rendering of the code.
Yeah.
The idea is to really show the concepts that frameworks provide. And in a certain sense, you would say, like, if you have an application that has a clear architecture where you have multiple instances of some domain concepts, by making the APIs that provide those concepts explicit, you can actually start creating those DSLs and then having models that show you those instances in your application. So it's actually, if you have an architecture, a clear architecture to your application, you can use those languages to show the elements in the vocabulary of the architecture, also to check rules, whether the architectural constraints have been followed and so on, and even do round-trip engineering.
In that case, the language represents, in some sense, the capabilities of your framework. Now, that kind of contrasts with some of the other approaches. Well, the MDA on paper and maybe intentional in practice, where you say you actually analyze what goes on in your domain, which is way more, let's say, business-oriented as opposed to technology-oriented. So that kind of conflicts, or how do you position you there? Is that just two different approaches?
It's not a conflict. It's just two different approaches that can naturally coexist. So in a sense, when you look at where DSLs can come from, I can sort of think of three sources. One being essentially domain experts already knowing exactly what they are doing and just observing it, and they typically already have a language, and a DSL can just make it explicit. And it's the example, for example, from intentional software using the insurance policy rules, and the business people seems, at least in that one case, are quite happy with how they can now describe the products in the policy workbench.
Yeah.
There are many other examples where you have a well-defined area of expertise with mature practices, where you can just come in and essentially harvest the existing language. Another source of DSLs are essentially well-established theories about a particular problem area.
State machines,
for example. So MATLAB Simulink with its block diagrams that essentially represents sets of differential equations. Those theories tend to give you a language that is kind of computationally complete and fairly universal. You know that any kind of system in that domain can be described, and there's sort of no fear that your domain-specific language is not mature. Another example I just recently saw is a language. I think it's called Flix. It's a colleague of mine at the University of Waterloo, Professor Keshav. He has a language for describing network routers, and he worked out first he did domain analysis of the problem, and he worked out formal semantics of the problem with fixed point semantics, and then came up with a language that's extremely beautiful and was demonstrated, and actually you can see it just from the abstractions that it can describe any kind of routing problem, and most of the existing protocols they tried to describe already, and it seems to be working very well. However, there is still a lot of problems out there where simply as a developer you don't know exactly the concepts of the domain. You don't even know what the domain boundary is. You have to adapt because the requirements are changing. So the only way you can do is try to build some kind of working model, and often you do it with a programming language, and try to distill some abstractions out of it. Well, that's you do it typically creating some libraries or frameworks, and gradually you grow this set of abstractions, and then you create applications on top of it by instantiating those things. And that's where this approach of framework-specific modeling languages, or putting the modeling languages on, or the DSLs on top of framework, comes in.
Let's look at an example. In the slides I looked at to prepare, we always prepare for interviews more or less. There was this nice example with the Eclipse framework. So why don't you give our listeners a little bit of concrete example what such a model would describe, for example, in the context of Eclipse editor parts, so people can understand more specifically what it's all about. You're
referring to this example. And by the way, I should mention that this is PhD work of one of my students, Michał Antkiewicz, an excellent researcher and designer and developer and so on.
Yeah, I know him.
So this particular example, so he's developed a language for looking at the code of a Eclipse plugin and understanding what workbench parts or elements such as editors, outline views, and property views are instantiated in the code, and how they interact in terms of high-level interaction, saying, for example, what kind of events such as selection events or part activation events are being sent between those parts. And in the code, it's normally not so easy to see. In order to have an interaction, such as sending the selection events, you have to register the parts with appropriate framework services. You have to implement appropriate interfaces. You have to write methods that return appropriate specialized objects like adapters and so on.
Yeah.
So in a sense, something that is maybe relatively a crisp concept in someone who is thinking about the architecture of the plugin, that there is a certain kinds of events being exchanged, is actually not so easy to find in the code.
Yeah.
So the particular sample language that he developed makes this explicit, and it allows you to retrieve those things from plugin code, and also allows you to do round-trip engineering between those this kind of models and the code.
So the model contains things like a workspace part has to implement this and that interface. Well, you have to send this event. You have to call those methods. Or something.
This is the meta model, and the model just says what are the things that are being done.
Yeah,
so
sure, yeah.
in that sense, the meta model just basically is a set of concepts, such as those parts and interactions, with features as properties of those concepts, representing those implementation steps, if you like, that the developers would have to do in order to get this concept to work.
You said that in kind of as a relative sentence, you said that you can actually extract a model from the code. So the model is not your primary artifact. You extract the model from the code, you change it, and then can you reapply the changes to the existing code base, I guess.
Exactly. So here's a very specific assumption that there's enough information in the code to retrieve the model at any time I want. Mm-hmm. And that just works for code and the kind of models that sort of rely that there are certain patterns, such as, for example, patterns of the usage of the API. And very often frameworks have a certain set of patterns how the API should be used.
Yeah.
So it's if you like, it's the specific architecture rules of the platform or the framework that allow you to retrieve those models, mm-hmm. right? And so it's a very specific kinds of models, but they're still nevertheless useful because they tell you about what components you have in your code and whether they follow various architectural rules and so on.
What we talked about now was to basically predefine the language, the meta model, manually, and then extract an instance from an existing piece of sample code. So that's and then resynchronize it back.
Yes, whereas the resynchronization, it's still non-trivial thing.
Yeah, because you don't just regenerate; you have to merge.
You have to essentially transform the existing code to make it consistent with the model.
Yeah, and I guess you do that on AST level, Eclipse integrated, the usual. Yeah. Okay, but you talked about another thing, and that is actually automatically extracting the language. So you give the system a bunch of example, in this case editor parts or whatever, and the system automatically extracts the configuration space, the variability, the language that you need to describe it.
Yes, that's a relatively new focus my students and I are taking as a direction, with the idea that the patterns of usage of those concepts provided by the frameworks, that they can be actually looked up in existing applications, and we've got with open source lots of examples out there typically.
Yep.
And you can use this to sort of understand how the framework's APIs are actually being used by developers. And you can mine rules, sort of like saying, if I'm implementing this class or this subclassing this class or implement this interface, I also have to make those and those calls. And out of those rules, you can actually synthesize those domain models or meta models representing the API rules. And in that sense, this gives you also a certain adaptivity in the sense that as new patterns emerge, you can actually propose new kind of abstractions to sort of take care of those new patterns and say, well, we automate them now because now we have an abstraction, or intentionalize them, if you like.
Trademark.
Exactly. So in that sense, it allows you to sort of grow the language. And the whole idea is that the language will never, in this context here, we just sort of say that there are situations where you don't have a language that covers all the variability points in all the choices and all the alternatives that you would like to have, and so it's automatically it's kind of partial. Whether it's a DSL that sits on top of another DSL or code doesn't matter. It's just automating certain kinds of patterns that you would have to type in the other language.
So just to re-emphasize, the fact that you're doing this on code and API level is not necessarily the only application. You can take basically, if you come up with a meta model, people use it, build models, you have a bunch of models, then you analyze those models with those rules and then take this as an input for evolution of the meta model. Like common stuff will be put into the language.
Exactly. And I could start with any level, grow the language to be more mature. And then once I'm using that language, I could start introducing higher level abstractions.
Yes.
Because once we have a higher level model, I mean, our software development trait has this property that whenever we have new tools that allow us to manage certain level of complexity, we just quickly go to the next level and we need some new tools.
Yeah. Yeah, this is actually really an interesting spin to actually mine language use in order to come up with ways of how to improve it. Very nice. Okay, Krzysztof, I think that brings us to the end of what we prepared. Thank you very much for being on the show, and hope to see maybe at some point another book that kind of maybe updates some of the things.
Yeah, I've been thinking about that, and maybe. The important project these days is my two-year-old son, and I'm still trying to cut down on my commitments rather than adding new ones, but who knows?
I was actually surprised that actually happened specifically with you, because you're known as quite a bit of a workaholic, I guess. So,
well, I'm working on it.
Okay, thank you very much. Thanks for listening to Software Engineering Radio. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@seradio.net, or if it's specific to an episode, please use the comments facility on the website so other people can read and react to your comments. This episode of Software Engineering Radio, as well as all other episodes, are licensed under a Creative Commons license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.